I'd like to welcome all of you to the next installment of the SEMA educational webinar. In this one, we're going to take your aluminum welds to the next level. So we got a lot of information to cover in this one as well, and I think you're going to find this a pretty interesting topic. I am Scott Van Hooley. I'm the manager of the Repairability Technical Support team here at ICAR and also OEM Technical Relations. I've been with ICAR for about 10 years. Before that, I was a collision repair technician where I did jobs start to finish and also did some estimating and even a little service advising when needed. So I've done a lot of different things in the automotive industry, and hope you enjoy today's presentation. And with that, turn it over to Brian.
Thanks, Scott. Yeah, Brian Watson's the name. Manager of Program Delivery is official title, but what are titles? Essentially, what I do for ICAR is I train all of our instructors, me and my team. So our 300 some odd instructors, we touch every single one of them, including welding, especially aluminum. My background is I worked as a collision repair technician, mainly focusing on the European type vehicles, and acquired various certifications through there. Did that for a number of years, and worked part-time for ICAR too. So got that experience too. And I joined up with ICAR full-time to expand my knowledge and skills and bring it over to ICAR so I can bring it ultimately to you. And that's the story on me without going into great detail. Eldon, how about yourself? You want to introduce yourself?
Yes, thanks, Brian. My name is Eldon Owens. I'm the Western Region Program Delivery Trainer, so I do work for Brian Wasson and on his team. Happy to be here today, and a little bit about myself is I've got about 25 years in the industry. I was a heavy collision tech for the best part of it. For the last couple of years, I've been full-time with ICAR, helping training our instructors. And prior to that, I was delivering classes and courses for ICAR. So glad to be here. Back to you, Scott.
All right. So we'll get right into the presentation here. Hot start and crater fill. What does it mean for you, and why is it important?
Well, hot start and crater fill is it's a feature in all these aluminum welders, and it's something you can use. I highly suggest you use it. But what it can allow you to do, it can allow you to more manipulate the weld and make it do things you want it to do. So you have a couple videos. Let's play those videos and check it out, and we'll walk through what you're seeing here. That first one was hot start was off. This next one, we're going to do hot start is on, but I want you to focus at the very beginning of the weld. I don't know if you caught it, but at that very first few seconds, about 2 seconds of that beginning of the weld, it was actually brighter. The weld was hotter for a very first few seconds. And what that allows you to do, it allows you to manipulate the weld at the very beginning to make it hotter before you actually get into weld. I got a couple samples. We'll go take a look at those, and we'll start that one up. So we'll get the camera switched over here, and you'll be able to see the difference here of the samples that you just saw. Okay, so the first one you have here is, this is with hot start is off. Now, what we end up doing is we call this tailing in. So you see here how this is really, the weld is really high, it's balled up, the weld is cold. So what's happening here is you're actually taking the cold part of that first half inch of the weld and moving it off the weld joint and then moving it in and then coming through the weld. You see all through here, it's all wetted out very nicely. And it might be a little difficult to see, but right here at the very, very top, there's a crater, or is what we call a dish. And it's what you can do is you can use the machines to be able to fill that crater. So now let's take a look at a sample that has hot start on and crater fill on. So here's an example. So hot start is on. We'll take a look at the very beginning of the weld here. You notice there is no tail end now, and it's not very tall. It's actually flattened out. So for the about first half inch of this weld, I told the machine to weld 60% hotter, and then it automatically churned up. And then when I got about half inch through the weld, it actually churned down itself. It just programmed the machine. These welders are like computers. So then when I got to the end, on the crater fill side, I told the machine to weld 40% cooler to fill that crater. So if you think about it in computer terms, all I'm doing is I'm telling the machine to do 3 different settings at certain times based on what I'm doing throughout the weld. And it's just a feature that all this equipment has. I hope that kind of explains it to you, and you'll be able to see where you can use hot start and crater fill to really fine tune your weld and what you want to do. Eldon, you have anything else you'd like to add to that?
Yeah, I'd like to add that, it's really important that if we're not using hot start, that we do use that tail-end method. That way that we can have that heat being built up into that joint and make sure that we got good fusion in the start of the joint. And so it's one or the other. You got to be able to, again, either tail in or program the machine for hot start.
Okay. So when we, kind of mentioned the programming of the welder, there's a lot of different adjustments on the machines. And so, Brian, where's one of the first places that we're going to need to start?
Well, one of the first things that you're going to need to start is you're going to have to know what the machine has in it. So all these machines are, you have to program them. You pretty much have to tell them what is in there. So what we're going to do is we're going to switch over to this camera. I got a welder sitting next to me here. We'll take a look at it, and so we can determine what's in the machine before we even move forward. So let's switch over to that one. And what things I'm going to be focusing on is the alloy, and I'm going to be focusing on the wire diameter, and also just the type. Is it aluminum? Is it brazing? And I need that piece of information in order to properly program the machine, which we'll show here in a little bit. So as you can see that this particular welder has three rollers in it. But if you see the sticker right here, the alloy 5554, 5554, that's one piece of information I need. The second piece of information I need is the diameter. In this case, it is 1.2 millimeters. Now I got to remember those 2 pieces of information because I'm going to have to tell the machine that that's what's in this particular drive roll. And I have to do the same thing for the brazing and if I was doing steel. But with these machines, you can actually set it up. I mean, I could put 3 different alloys of aluminum in here. I could have 5554 here and 4043 down here. I just have to tell the machine that, hey, this is what's in it. So that's the first piece of information whenever you're working with some of these welders is you got to know what's inside it.
So Eldon, we've talked about some of the different welding types. Are there machines and settings and things like that when we're going to program a welder? There's similarities between the different types of welding we're doing?
Yeah, there is quite a few similarities. I'm going to go ahead and I'm going to walk over to this machine and kind of point out some differences on it. And so that way, differences and similarities, and that way we can kind of get a better understanding of what we're talking about. So I'm going to go ahead and head over there now, and that way we can talk about it. So a couple things that I really want to talk about, as far as similarities, our gun setup and all of that, is really identical between welding steel, welding aluminum, and all of those concepts. So, like what Brian was talking about, knowing what alloy material we have in there, it's just as important also with the steel to program these welders to accept that alloy and the thickness of the wire, and also as we're setting them programs up for our gas types and all of those other things. A lot of the welding techniques, and we'll kind of get to that in a little bit, are very similar, other than we'll have a little bit more stick out. So, Brian, what are some of the other similarities that you see?
Well, so I always like to say, if you learn how to weld aluminum well, it just makes welding steel that much easier because the same principles apply, essentially. Travel speed, contact tip to workpiece distance. If you look at the welds that are done in the factory, they're done by robots. So essentially, we need to learn how to weld like robots, which is, easier said than done, but it's really a refinement of technique. I like to call it muscle memory. If you build the proper muscle memory for the same weld, you're going to get the same results. What I end up finding, especially in our trainings with the industry in general, is the refined technique of knowing that muscle memory of doing a vertical up weld, for example. If you always do that same technique always through and it's repeatable, that technique, then when you make adjustments to the machine, you'll be able to see changes. So, but if your technique and you're making adjustments to the machine, you're actually changing two things, because you can change the profile or the penetration, a lot of different things with the weld with your technique, but you can also change it with the machine. The trick is, to make your welds better, especially your aluminum welds, is get a refined technique so you have that repeatable technique and you can repeat it over and over and over again. And then that way, when you're adjusting the machine, you know what's changing and you can go from there.
So, Eldon, do you want to go ahead and show us some of the different, you're talking about travel speed and things like that. You mentioned stick out. Why don't you go ahead and show some of the different techniques that you can make some adjustments to your weld just by adjusting your technique?
Okay, I'd be happy to. And so like what Brian was talking about, with being technique and being more like a robot, aluminum is a little bit more critical than what steel has been. With steel, it's a little more forgiving, and so making sure that our stick out is exactly where it's supposed to be. So we want a little bit over a ½ inch, somewhere in there, stick out. If we start moving our gun in and out, we're going to have that fluctuation in the weld and also create problems. It's like Brian was talking about, making sure that that technique stays the same, that we carry that gun angle through, and that we're always pushing that weld. That's critical with welding aluminum. With steel, either pushing or dragging, depending on what you're trying to achieve. With aluminum, we're always pushing. That way, we're creating that scouring effect and pre-cleaning that aluminum so that we get a good, clean weld. A couple of the other things, again, is body position. Make sure that we're comfortable, that we can go ahead and perform the weld. I like to do a dry run. Make sure that there's nothing in my way, that I'm not going to bump into anything. And that way I can get good, repeatable results, and that I'm not chasing me as the welder, but I can fine tune the welder to achieve what I need in my repairs. Brian, do you have anything you'd like to add to that?
I think you covered all the bases. Yeah, I mean, just like you were mentioning, get that technique down pat before you start messing around with the machine.
Yeah, I really find, individuals that weld really well with steel, and have a good technique, moving over to aluminum seems to be a fairly easy transition as soon as they understand the subtle differences. That technique, I found with trainings that we've done, it becomes really difficult to create that muscle memory and the good habits needed.
So, Brian, I think there's a lot of different things here where people get a little overwhelmed with all the adjustments and things like that on the machine. What are some of the different things that we need to pay attention to when we are adjusting these machines?
Well, no matter what machine you have, they all do the same thing. What we've ran into and what we typically train is, where are the buttons? One manufacturer might call hot start one thing, and the other manufacturer might call it completely something different. But really it boils down to, both machines do hot start. So, and that's really where most people struggle. And if you understand the basics of what all these machines do, between hot start, crater fill, I mean, there's a lot of different terms whenever you're talking about these welders, but when it really boils down to it, they all do the same thing. You just have to figure out where those buttons are, what they're calling this particular feature something, and what does it do. So it's finding out all the features, buttons. What I found most helpful is, don't be afraid to play around, go into extreme. So if you find a setting in there, go high, go low, see what it does, experiment. Experimentation can actually help you learn your equipment that much better. And you don't have to be afraid that you're going to mess up the programming because you can always turn it back to factory reset, which I'll show you later on.
So with all the different buttons that you mentioned, do you want to kind of take us through the machine that you have over by you and just kind of walk through some of the menus?
Sure. Yeah, I got the car liner machine over here. We'll switch the cameras over, and I'll show you the user interface so I can show you some of these buttons and features. So right now, what you're looking at the basic user interface. And if you remember earlier, I was talking about you got to know what wire, alloy, and what wire diameter is in there. So on this particular machine, and it doesn't matter what machine, if it's you have to tell it what's in it, and it's called a program. So in this one, I got a program. I got AL 1.2 millimeters, 100% argon gas, and it's 5554. So essentially, I have told this machine that's what's in it. If I need to change it, I just push this button. I go through a selection process and pick which wire, what diameter, what alloy, and I'm telling the machine, okay, that is what's in here. There's some other things you can adjust on here. The key thing to remember, just like on a steel welder, you still have wire speed and voltage adjustments. The only difference is the way you're moving it up and down. In this particular one, and most of them, they all adjust with one knob. But one thing I want you to focus on, I want you to focus on this number, which is the amps, this number, which is the wire feed speed, this number, that's the volts. Don't pay attention to the material thickness right now, because I'm going to reference. And as I turn this machine up, you're going to notice that all three of those numbers change at once. So I'm increasing amps, I'm increasing wire feed speed, and I'm increasing voltage, all with one knob. And it does the same thing on the back end. Now let's say, for instance, let's say you wanted to make the bead profile a little bit taller, or make it flatten out a little bit. Typically what you do in a steel welder is you adjust the voltage to do that. Well, you can do that with this machine. So if you see up here on this knob, again, I want you to focus on these three numbers: amps, wire feed speed, and voltage. So when I turn this knob, one thing you'll notice is that only the volts is changing. The amps and the wire feed speed is staying the same. So essentially, I'm doing the same thing as I would as a steel welder. It's just I'm doing it in a little bit different way. Fortunate thing about this one, if I go on one extreme, you can kind of see they got a little graphic here that kind of shows you what direction you're going in. So you can go one way, and then you can go the other, and it shows you how the bead profile is changing. But we were talking about hot start and crater fill and some of these advanced features. So let's go take a look at that real quick. Let me get this back to where it needs to be. There we go. So now I'm going to go into the advanced features. And first thing I'm going to do is I'm going to come, they call this the secondary menu button. So it's kind of like a set of settings behind the main screen. That's what this is. And I want you to pay attention to this graph, because this graph helps out quite a bit. Every single one of these points is a feature of this particular piece of equipment. And I'm going to explain what each one of these do. So pre-gas is just the amount of time it takes for the solenoid to turn on and create a plume of gas before the arc starts. I can adjust this time either up or down, depending on what I'm trying to achieve. If I go to another click, I got soft start. So soft start is, think of it as back to that wire feed meters per minute. If it was 5 meters per minute, what I'd be doing here is I'm telling it to start slow and then work up until it creates an arc, or some call it a soft arc, or it just makes the arc light up a little bit faster. So if you find when you're welding and it always pops, or it just the arc doesn't start out all that great, it takes a second for it to solidify, try playing with soft start, because that's what that adjustment's there for. Right now, this on default. Going to the next one, now we're into hot start. So I was mentioning before on those welds, I said I went 60% hotter. So if I just turn this up to 60%, now it's going to weld 60% hotter, and I can tell it for how long. So hot start percentage, and then I go to hot start time. So if I put this at 1 second, I'll say 1.5. Say 1.5. What I just programmed this machine to do, I told it weld 60% hotter for 1.5 seconds, and the machine's automatically going to do that when I pull the trigger. So when I pull the trigger, it's going to weld hotter for 1.5 seconds. The slope time is how long does it take to go from that high setting of 60 60% hotter down to my normal welding. And generally, you have that around a second. You know, you don't want a hard transition between the 60% hotter and the normal welding. You kind of want it to slope down into it, and that's what the slope value is. Moving on to the next one, now we're down into the crater fill part. So this crater fill, it kind of works the same as hot start, except it's the other direction. So first thing you do is set the time. How long do I want crater fill to go? So we'll say for a second, and if I go to the next one, it tells me the actual current. So in the example I showed you, I told it to weld 40% cooler. In this particular case, what I just programmed in there is it's gonna, when I let go of the trigger, it's gonna weld on its own for another second at 60% cooler. And I just programmed that in the machine. And you can change those values. You can go higher, you can go lower, you can have it weld for 2 seconds instead of 1 second. It's all adjustable. The last few settings, we have post gas, which everything's done. The arc has been turned off, and you always want a little bit of post gas in there. 3 seconds always seems to work. It just allows the weld puddle to cool down and solidify before you actually pull away. So back when I was talking about technique with Eldon, when you're using these features, you really have to keep in mind what is going on. So when you pull the trigger, yeah, it's going to weld 60% hotter. You weld, 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 weld. You get to the end, you let go of the trigger, it's still welding for a second. And then when it's done welding, post gas is going to happen for another 3 seconds. So when you let go of the trigger, you're going to need to stay in that spot for 4 seconds at the very end of the weld to let the programming finish what it's doing. And then we're back at the beginning of the settings. So those are some of the features. I can tell you that most of the equipment out there has all of these features. And if you open up the user manual, which you should got one, if you don't, you just contact the manufacturer, and I'm sure they'll be happy to send you one, and you'll find all that information in there. The hot start, crater fill, slope, all those are general terms that they should know about. So you just ask them where the buttons are, and they'll get you straightened away. Eldon, do you have anything else that you want to add? What was your experience when you started playing with some of these advanced features?
You know, it was kind of a challenging experience, to be honest, you know, to get used to making sure that you was following that program and holding the gun into position for that period of time. You know, coming from welding steel on a traditional welder, kind of get used to pulling the trigger, you know, and just watching the puddle and making sure everything's happening. But now you're actually having to program the piece of equipment to do these features. The one thing that I have liked about it, though, is by advancing into more of the advanced features on the welders, it does make welding aluminum a lot easier. It takes out some of that guesswork. It's just kind of experimentation, like you said earlier, and figuring out where your settings need to be able to achieve the welds that you want to achieve. You know, and then again, it's really, like you said, understanding what that equipment is capable of and programming it to do it.
So I know we kind of talked a little bit about the programming of the welder, but Eldon, can you just explain a little bit the difference between like a 2T and 4T trigger?
So Brian was talking about, you know, programming. He was talking about programming in 2T for the hot start and the crater fill. And that's really where he was setting time and making the welder actually do the job for him. When we move into a 4T trigger, or some call it a 3L, you know, there's a couple different terminologies out there, so we need to be careful about, you know, how we classify it based on the equipment maker, you know, that we're using. The 4T trigger really gives me as the welder the control for the time of that hot start. So I go ahead and I program in the percentages, just like Brian was talking about, so that's 60%. But instead of telling the machine to do that for that second and a half, I really control it by my trigger pull. So the way it works is I would pull the trigger and start welding, and that's my hot start. So it's my set current plus 60%. And that continues for as long until I let off that trigger. The moment that I let off the trigger, then we bring that slope back down to our welding current and then perform our weld once we're happy with that burn in and that puddle has really created the penetration and the fusion that we're looking for. When I reach the end of the weld, to stop the weld, I'll actually pull the trigger again, which now initiates the machine to go ahead and move into that crater fill. So now it's going to go ahead and ramp down into that 40% or 60%, or so 40% less than 60% of my current until I release the trigger, and then we go into that post gas. So again, I have to hold the gun for that 3 seconds until that puddle solidifies and it's protected from the environment. So I kind of hope that makes sense. Brian, do you have anything you would like to add to that?
Yeah, I would say if you're gonna experiment with 4T, make sure you fully understand hot start and crater fill and the times, because essentially what you're just doing is you're eliminating the timers. The hot start time, we set it for 1.5 seconds earlier, and you're limiting the crater fill time, and you're controlling it with your finger. And that's really, but you really got to have a base understanding of how all that works before you turn 4T on, because it's strange to weld without holding down the trigger and doing different things. But I will say, when you finally get to the point where you're utilizing all the features and functions of this equipment, when you have 4T, you essentially have 3 welder settings at your fingertips at any point while you have the hood down and you're welding. At any point, you could switch to hot start, crater fill. You have 3 different settings that you pre-programmed into the welder, and you can access them at any time. There would be a lot of times where I would be welding on a vehicle and something went wrong. It happens. You had a blowout. Some got too hot, got too cold. Well, on the fly, I could easily flick the trigger a couple times and go directly back into hot start, or I could flick the trigger again or go into crater fill and just continue on with the weld, because I essentially have 3 settings at my fingertips that I could use at any point during that weld. Because we all know that, yeah, the welds don't always come out perfect, especially on the vehicle, and it's nice to have that flexibility for when it does go wrong, you have some abilities at your fingertips.
So, I think we've talked a lot about some of these different features, and it really, I think a lot of people think that they can just buy a new welder and that's going to solve all their problems. Or just do all these things for them and it'll be amazing. But if you don't get in there and experiment and learn the machine and learn what it's doing, I think you're going to be at a huge disadvantage, and your guys probably aren't going to use the machine because it just doesn't work for them because they don't understand it. So I think that's some really great tips. I think we'll move on to double pulse and explain that. We got some videos here, and we'll start that up in the PowerPoint. So, Brian, do you want to explain a little bit what they just saw in that one?
You just saw a normal pulse. So, I mean, pulse it's a pulsing of voltage. So you're going from a high voltage to a low voltage, and it does it very, very fast. Double pulse, it's a pulse of. So, yeah, you're pulsing voltage still. Double pulse is now I'm pulsing the settings. So I'm going from a high setting, low setting, high setting, low setting, high setting, low setting, which you can tell the machine to do that. If you play the next video, you'll be able to hear where it's going high, going low, going high, going low.
So, Eldon, what's the benefit of double pulse in this situation?
Double pulse is actually very beneficial for the thinner aluminums. So welding on thin gauge exterior panel on the aluminum, double pulse really gives you the control that you need to not overtip the steel. And so I get a lot of questions about how to weld cracks and all that kind of stuff, or if I have a tear, how am I going to weld that up? Really, this is where you get into the advanced features of the machine, and you're going to utilize the double pulse and the hot starts and the crater fills to achieve that repair. Now, it doesn't always work to just move into double pulse. Oftentimes, when you get into a thicker material, something like in a piece of the structure of the vehicle, double pulse isn't going to really give you the benefits that you want. And so it may be necessary, or you may want to step back to the single pulls. And that way you can have a little bit more heat, better control of the weld.
Brian, anything you'd like to add on that?
Double pulse is fun. So what you can do is, you're talking about welding a crack. It's actually, if you get the welder tuned just right, you can weld. I've welded a 4-inch crack, 4-inch long crack in one single pass using double pulse hot start and creator fill. And this equipment can do it, but you got to be able to tune it in. And double pulse is really what helps. Like I was saying, it's not. You're not pulsing the voltage. The pulse of the voltage always happens. You got to think about what double pulse is a heat management setting. So it's kind of like I'm bringing in the heat, then I'm pulling it out. I'm bringing in the heat, then I'm pulling it out. And you can set how fast you want that to happen. If you want that to happen real fast or real slow, and that's all in the advanced feature setting. If you want it to be in the high setting for longer and then go back to a low setting, you can program all that information into the welder. Biggest thing is experimentation. Get some scrap together, mock up some welds, and just play. So
yet another example that no matter what kind of welding we're doing, we have to do practice welds.
Oh, definitely. Yeah. I mean, it's just like riding a bike. You know, you get good at riding a bike, but you learn how to do wheelies and ride on the front bars, like all the stunts. I mean, they took a lot of time to practice to learn how to do that. It's the same thing with welding. If you spend some time in practice and hone your skills and hone your knowledge by getting into the machine and understanding how it works, it just makes it so much easier for when you actually have to perform that weld on the vehicle. And it saves you time too, because you're not having to chase around the quality weld you're looking for, because you've already experimented on scrap months and months and years ahead of time. In total, I've been welding aluminum for about 15 years, and I started out with the European vehicles, and they force you to use all these advanced features, and that's what really elevated my welding skills and abilities, was that force to jump into these features and force me to do it. But once I found them and I started utilizing them and understood what they can do, it's very, very powerful.
So, we're talking a little bit about the practice welds and things like that, but Eldon, I know there's been a lot of times where people have said they don't have time to do them because they're in a high production shop and they don't have the time to make them. What would you say to somebody on that?
I would say you have to make the time. Just like Brian said, until you have your skills honed, you really don't want to be doing test welds on a customer's vehicle. We need to make sure that whatever we're doing and the settings that we have with that equipment is actually going to produce the welds that we need. So making sure that we're doing those practice welds and the destructive test to verify that the settings are correct and that our technique is correct. And so people that say they don't have time, I say make the time.
All right. So we're going to move on to the next slide here that we have to talk about. And so Brian, okay, we were making we did our practice welds, but now we're having trouble. Where should we begin?
It always happens. You always got to figure out what you messed up. So there's a magic button on all these welders called the factory reset. So let's go over to this car liner machine, and I'll show you where the factory reset is on here. And what essentially does is it wipes out anything that you did before and puts it back like it came off the factory floor. So we'll go take a look at that and see how you can access and reset the machine. So let's say I was experimenting and I got all lost and I didn't know what I did. I changed all kinds of things. I need to get this thing back to base settings. So every single one of these pieces of equipment has it. In this particular one, it's in the gear setting. And if I scroll down, I go to service. And if I scroll down some more, there'll be factory reset. And all I do is just tell it, yes, factory reset. You don't have to worry about breaking. So the thing you got to remember is this thing is just a computer. This is a computer, and I just told it, hey, go back to the way you came out of the factory. Now, everything that I just did, I undid. So all that hot start programming and all that, it's just been undone, and now I'm back to square one. And that's really where it helps out. So you're free to experiment because you always have that escape button. And every single one of these welders has a factory reset. The procedure may be a little bit different, but if you look in the owner's manual, it's usually listed in there on how you can factory reset.
So wait, we actually have to look at that manual?
Yeah, they all come with them. You know, they're well, some of them are in different languages, so you got to make sure you get the English version first. But yeah, they're quite detailed in there, and you know, there's training available that shows where all this stuff is.
Well, Scott, I'd like to add that even there's a lot of online resources for a lot of this equipment that technicians can utilize to help them figure out the different settings that they can use and that.
So, okay, so we were playing with the settings on the welder, realized that we screwed it up royally, and we did the factory resets, but we're still having problems. So let's talk about that upper left picture, and what is that weld telling us? Alden?
Welds telling us that we got a wire speed issue, you know, and so that can really lead to a lot of different things. You know, and so if we verify, you know, the factory reset, verify all of our programming's correct, you know, and making sure that, I'm going to really start going back and looking at the machine. We could even have a voltage out of balance, you know, and so we want to make sure that them settings are correct first. After that, I'm going to really just go back to the basics. You know, I think that's kind of one thing that we really forget is these welders are just kind of going back to the basics. You know, so I'm going to check my spool brake. I'm going to check my roller tension. I want to make sure that the rollers are the correct size for the wire that I'm using. You know, we see that quite a bit or quite often in shops where technicians are changing different types of alloys and that kind of stuff. You know, and if I don't find issues there, then I'm going to kind of dig in a little bit deeper. You know, do I have some gunk in my liner that possibly is causing some friction? Or do I have a liner that is broke down and needing replaced? You know, the other thing would be is contact tips. You know, they are a consumable item and they do need to be replaced. You know, and so that would be another area that I would look at.
So we actually had a question from the audience. They're asking, with the welding wire, can we just leave it in the machine? Do we need to do anything special with it, especially if we're not going to be using it for a while?
Yeah, definitely. You should, so aluminum has a natural tendency to form what they call aluminum oxide. It's a protective coating that all aluminum does. So if you're not going to be using it, I always say if it's going to be in the machine longer than a week and not being used, pull the spool out of the machine, put it in a Ziploc baggie, somewhere that isolates it from temperature and humidity. I usually put it in a Ziploc baggie and then put it inside the office or somewhere where it's cool and dry, and that will ensure that that spool of wire stays fresh and doesn't form aluminum oxide on it. If you have a spool of wire that has a lot of aluminum oxide formed on it because it's been in the machine too long, what you'll end up finding is as you're welding, you'll actually see black soot material in the weld puddle. And when you go to break the weld, it have a lot of porosity in it.
So, in the upper right picture, we have inside the machine. What are some troubleshooting things that we're looking at when we're looking at the rollers and the adjustments?
Again, just making sure that the correct roller is in the machine for, you know, also the size of the roller for the groove for the wire to feed through. If we're trying to run 1.0 wire through a 1.2 roller, we're going to have slippage, and that's going to create some of them wire feed issues. You know, so really going back to basics and looking, if we're having that, you know, variable arc, you know, where it's just changing back and forth constantly, that really comes down to that wire feed issue, and we need to check those things out.
So, Brian, on that lower left picture, what are we looking at there, and what is that weld puddle telling us on that one?
Oh, it looks like that weld puddle, we got too much voltage. I mean, back when Eldon was talking, a lot of these troubleshooting, when you verify that the software, the computer side of the welder is fine, you know, it's been factory reset and all the programming, you've told it what wire's in it, you're really down to hardware. And at that point, you're into the basics of welding. So it's always, is there a balance between voltage and wire speed? In that bottom left picture, if you look at the top weld, there's too much voltage and not enough wire speed. So why? Why is there, do I have the wire speed too high or too low? Is there some sort of setting that I'm not looking at? So that's something to keep an eye on. And when you're starting to see issues laying down on the actual material you have, and you've already verified that the machine is all set up properly, that's probably the key point, that I got it programmed and all the stuff I've been messing with has been removed. I'm down to the basics: voltage versus wire speed. And that bottom left picture is definitely a high voltage situation, which could be, you know, maybe there was a spike in the infrastructure. So instead of getting 220 volts, it's getting 230, which the machine will compensate, but you never know. You just kind of have to narrow it down. But at least you know that it's voltage you're hunting down.
And so that bottom right one is really, you know, aluminum's great. It shows you all the sins if you're not using the correct technique. So Eldon, why don't you just touch base on that and what that picture is really telling you?
Yeah, that picture, you've got a lot of black soot around it, you know, and so there's a couple things, you know, that really could be causing that. One could be technique, you know, and so if we're not pushing that weld, we're going to get a lot of soot because we're not getting the protection around it. Another could be gas flow. You know, we need to make sure that we actually have the correct flow rate of the argon gas at the nozzle. You know, setting the regulator is one thing. That kind of gives us the baseline, but we do need to measure it right at the nozzle to make sure that we do have coverage for the aluminum. You know, another thing that Brian kind of spoke on earlier in the question from the audience, you know, is contaminated wire. You know, aluminum oxide does form on aluminum immediately. You know, that's one of the benefits of aluminum and using it, is because it does have that corrosion resistance. You know, and so this could be a case of where we had some contaminated wire, or even the aluminum wasn't cleaned good enough for the weld being done.
Eldon, I want to pop quiz you. What's the purity of argon gas? What does it need to be?
99.9.
99.9. You missed a 9. It's
0.99. 0.9. Thanks, Brian. You know, and you bring up a very interesting point because we have seen cases where some argon gas has been contaminated. You know, and so if a bottle gets swapped over onto a machine and you start seeing this kind of stuff, you know, don't rule out the argon being contaminated. You know, if you find it in the middle of a bottle, you know, where you start seeing this kind of soot and that, you know, it's probably not the gas.
I've come across 5 bottles that have been contaminated in my career. And every single time when I talked to the welding supply, they ran out of 100% argon bottles, and they had to convert some bottles from C25, which is 75-25, 25% CO2, to 100% argon. Well, you know, the guy that was doing that particular work, he didn't go through the proper procedure for purging that C25 tank fully, because there's a whole procedure you got to do to get all that CO2 out of there. So by the time I got it and they refilled it with argon, it just had a trace amount of CO2 in it. So when I went to weld, it was just, it never turned out well. It was very black and sooty because it just had the purity of the argon was lower than 99.99%.
So, you know, that's a kind of interesting thing. I hadn't heard of that before. But what are some of the common signs of problems, and what do you guys see when you're out in the field that technicians often run into that cause them the most issues?
A couple things that we see, you know, that's really common is probably programming is probably number one that I see. You know, making sure that the machine is into the correct program, and because without that being done, the machine really doesn't know where that synergy curve or where anything needs to be as far as the voltage and the wire speed. You know, and so that's one of the bigger things that I see, is making sure the programming is correct.
The other piece I see is maintenance, just taking care of your equipment, changing out having contact tips, having a replacement liner, cleaning out the rollers periodically. I mean, if you got dirt and grime and body dust and all this stuff all over the rollers, well, all that stuff gets on the wire. It doesn't magically, you know, disappear. So just regular maintenance and taking care of the equipment is probably the second biggest thing that I come across.
We actually have another question from the audience. They're asking, is plug welding technique different than steel?
For me, well, it varies on person, but for me, I use the same procedure whether it's steel or whether it's aluminum. And essentially what I do is I hold in the middle of the weld for about 2 seconds, and that gets me my penetration. And then I'll go like a clock. I'll go down to 6 o'clock and then go all the way around the clock. one time. And whether it's a steel weld or aluminum weld, it's the same procedure.
I think that kind of actually brings up a really good point. This is where the advanced features really come into play or benefit, is doing that plug weld. I find by doing that hot start, it allows me to get that penetration that I need a lot quicker, and then I can perform that plug weld. As opposed to if I'm not using that hot start, we talked about that tail end process and having to heat up that aluminum to be able to get it to start to flow. We really have to push that material through if we're not utilizing hot start.
I suppose if we didn't have hot start on, we'd have a big cold spot right in the center and then have to weld around it.
Yeah, you just kind of have to keep pushing at it until it'll flow out and create that penetration into the base material that we need.
That sounds a lot harder than we want it to be.
Yeah. Again, it's the advanced features, getting in there and utilizing them for our benefits.
Okay. So I think that's about it for today. We do have a few training courses around some of this, and Brian, you want to just kind of touch on some of the welding courses that we have available?
Sure. Yeah. So what you see here, top two left, training and certification aluminum GMA MIG welding and aluminum GMA welding theory. Now, the way those are structured out, you actually want to take the theory first because that covers synergic curves, talking about some of these advanced features. What is poles versus double poles? What's happening? It gives you all the background information. So when you get into the training and certification, which is the hands-on portion, you have an instructor working with you, like Eldon or myself or any one of our instructors, and we've worked with you on those techniques, refining techniques, and getting to welding like a robot, I guess is the best way I could put it, and then also adjusting the machine to match the welder. I think that's one of the big misconception is a setting that might work for Eldon is not going to work for me, and vice versa, because you're really matching the machine to how I weld versus how he welds. So that's what we cover there. And of course, at the very end, we administer the certification tests, which is 7 welds that are measured on some visual and destructive criteria, which are all published on our website.
I'd really like to make a plug on those other courses that we have listed there, for the Chief and the GYS and the Pro Spot and Carl Liner. If you're wanting to learn more about your equipment, I have found these courses got a lot of information that goes a lot more into detail about that specific piece of equipment and the advanced features and how to get there and navigate it.
We're going to show you where the buttons are.
All right. Well, with that, I'd like to thank everyone that participated today. And if there are any additional questions, make sure you post those into the YouTube channel, and we will be monitoring that and responding to your questions. And with that, thank you and have a great rest of SEMA.